Hi everybody and welcome to the final part of our Snowboard Tech Guide video series. Now in this final episode we're going to take a look at snowboard bases. We're going to go through the different grades of base material, look at how they're manufactured and the difference in terms of performance between the most commonly used materials. Now once we've done bases, we're going to finish off the whole thing with a quick look at the final element of the board's construction, namely the sidewalls and the edges. So let's start with snowboard bases. Now the first thing to look at is what a base actually does. Now I know that sounds like a stupid statement, but having an understanding of how the base helps the board glide really does help you see why manufacturers use certain types of material and why some materials give better glide than others. Now the best explanation of how the base works is to say that its main function is to improve the coefficient of friction with the snow, and what that really means in layman's terms is that it's there to make the board slide better. So let's now take a look at the different types of base material and how they differ in terms of performance and durability. But before we do that, it's probably worth dispelling a few myths about snowboard bases first. Now if you follow snowboarding closely, you'll generally know that bases come in two styles. These are extruded and sintered. Now the general perceived wisdom is that extruded bases are cheap and offer poor performance, while sintered bases are expensive and give better performance. However, the reality is a lot more complex than that, because in some conditions and riding styles, extruded is actually better than sintered. Now before we go straight to why that is, it's worth looking at the differences between the manufacturing process of these two different materials, as this is going to give you an insight into why there's such a difference between the two in terms of performance. So, the starting point for both types of base is UHMWPE plastic, which stands for Ultra High Molecular Weight Polyethylene. Now this is a tough and durable thermoplastic that has a high resistance to abrasion and a very low coefficient of friction. So obviously it's perfect for use on things that slide. Now in both these base types, the raw material comes in granular form and goes on to one of two processes to be formed into a sheet material, depending on whether it's going to become an extruded base or a sintered base. Now the first of the processes that we're going to look at is for extruded base. Now extrusion is the easiest process to explain, as it's a relatively simple manufacturing process. It starts with the raw plastic granules, which are fed into a sealed vat. This is then heated up until the plastic granules melt and turn into a liquid. This molten plastic liquid is then forced through a flat die and a series of rollers to be formed into a sheet material. Now once this sheet material is cooled, the upper surface is then chemically treated to create a rough finish to enable resin to bond to the surface during the board's construction. The bottom surface is left smooth, creating a low friction material that slides well across a wide variety of snow conditions and temperatures. Now extruded bases have always been pretty simple, as there was just one type. However, over the past few years we've seen extruded bases become available in different densities, and these are formed in exactly the same way as the traditional extruded base, the only difference being that the liquid plastic is put under a lot more pressure before being extruded. So this means that when you open the die, the pressure forces more liquid plastic through, creating a denser base material. So what do extruded bases actually bring to the party compared to high spec sintered bases? Well, there are some quite distinct advantages as well as obviously some disadvantages. Now the key advantages are it's cheap to make, so it reduces the overall cost of the board, allowing the designers to use higher quality materials for the internals. It's also easy to repair because it's softer than sintered base, and when you melt that plastic, the repair has the same properties as the original base material. However, its key advantage is because you've got that smooth low friction finish, it's actually faster in its natural state than most sintered bases. And what this means is that if you're one of those riders that doesn't wax and service your board very often, then an extruded base is potentially quicker for you. Now the downsides are obviously that softness, so it's less resistant to impacts and damage, and it doesn't hold wax like a sintered base, which means that in real terms it's slower than a well-maintained sintered base. So, moving on to the next base material, which is the sintered base. Now, as I said previously, sintered bases are harder than extruded and have better wax holding properties as well. However, the downside of sintered bases are to be quicker, they need to be serviced regularly. If you don't, they can dry out and actually be slower. They're also a lot more expensive to produce, so can add a premium to the cost of the board. So, what is a sintered base? Well, the starting point is actually the same as the extruded base. So you start with that UHMWPE granules, but this time those granules are placed into a tubular mould. This is then heated gradually, and as the plastic granules start to soften, they're then compressed under high pressure so they start to bond together. Now, as the granules haven't fully melted, it leaves air pockets which are similar to pores throughout the material. This is then left to cool, creating a dense plastic billet. The billet is then removed from the mould and now resembles a large Swiss cheese. This billet is then placed onto a machine which rotates it across a large blade. The blade then shaves off the sheet material, which, as per the extruded base, is then treated on one side to create a sealed rough finish that's ready to bond to the board. Now, the beauty of manufacturing bases this way is that it's possible to manipulate that density of the material, allowing the designers to offer harder bases with improved wax holding. By using finer granules during the sintering process, you end up with a denser material with smaller pockets of air. This creates a harder and more durable base. However, because of that increased density, it's a base that's also harder to wax as those air pockets are smaller. So you've really got to work the wax in a lot more than you would with a regular sintered base. However, once you've got that wax in there, it's going to stay in there a lot longer. So you're not going to have to wax it anywhere near as often. Now, these different base grades are generally categorized by numbers. So a regular sintered base is usually classed as a 2000 grade, going up to around 9000 for the hardest grade. So to give you an example of what that means, a 2000 grade base has a molecular mass of around 3.5 million Gmols, whereas a 4000 base has a molecular mass of around 9.2 million Gmols. Now, before we go to the next section, it's probably just worth mentioning why you actually wax your board and what that actually does. When you wax your board, you're going to fill those pores with liquid wax, and once it's cooled, you'll then scrape off the excess, leaving the now solid wax in the pores of the base surface. This remaining wax creates a really hydrophobic surface which repels water. By forcing the water trapped between the base and the surface of the snow to bead, it's forced away from the surface of the base, reducing friction, therefore giving you a faster glide. Okay, so let's finish off this section on bases by just quickly taking a look at base additives. These additives can be added into the raw materials during the sintering process and can add additional performance to the board. Now, the first additive that we're going to look at is the simplest, and that's wax. By adding this to the sintering process, it fills the pores throughout the whole material, increasing the hydrophobic properties of the original base material. And that's going to improve the glide in between surfaces. You still need to wax this type of board though, but it just means it won't become really slow like a traditional unwaxed sintered base would. Next up, we're going to have a look at Electra. By adding a blend of carbon and graphite to the base material during the sintering process, you get a base that dissipates both heat and static electricity, reducing water film that creates suction and drag. To be honest though, this type of base is only really going to bring any advantage at higher speed where you have increased friction that allows the base material to heat up. Finally, we've got gallium. Now, this is a relatively recent addition to base material and it's quite popular on salon boards. So what does gallium do? Well, basically it bonds together with the wax particles to create a tougher and more durable wax gliding surface, meaning that you're not going to have to wax your board so often. So that's bases done. Let's now quickly finish off this video with a little bit about edges and sidewalls. So to start off, we're going to talk edges first. Now, the purpose of the metal edges on a board is to provide traction with the snow when turning. The sharp corner cuts into the snow and engages the board throughout the length of the turn. It also adds protection to the side of the board. Now, snowboard edges are measured in the Rockwell hardness scale, and this is a test which is done by measuring the depth of an indentation of a large load to determine the hardness of the material. Snowboard edges usually come in between 41 and 52 for a regular board, through to around 60 on higher end carving boards. So the question is, why wouldn't you just use the hardest edges all the time? Well, it's not quite that simple, as hardness doesn't always equate to strength. As you increase the hardness, the edge can become brittle. Now, while this isn't so much of an issue on something like a race board where you want maximum sharpness and you're not really going to impact anything hard, On a jib board where that edge is going to be slamming into hard surfaces all the time, it's going to become a problem. And that is the reason that you'll see manufacturers using different edges on different types of board. So for a regular board, you're usually going to be looking at between 46 and 50 Rockwells, and that's going to give you the ideal balance between hardness and durability. Whereas for a jib board, you'll generally be towards the lower end of the scale, where the edge is going to then deform on impacts rather than crack. Now, you'll generally notice when brands use this because they'll call it out with a snappy marketing term. Call it jib edges or anti-crack edges or some other term like that. So, the final part we're now going to take a look at, and the bit that finishes off the board, is the sidewalls. Now, sidewalls always used to be a really simple topic. They basically just sealed the core and gave protection against impacts. However, as with most things, they've just got more complex over the past few years. Instead of just protecting the core, they're now also used as shock absorbers. There's a couple of ways that brands use the sidewalls to dampen out vibration, and the first of these is to change the type of material that's used in the sidewalls. Now, historically, sidewalls were always manufactured out of ABS plastic. This material is strong and durable, so it's great for adding that protection. However, because of its rigidity, it has very little ability to absorb vibration. So, over the past few years, we've seen more and more brands start to introduce sidewalls constructed from either a combination of urethane and ABS or 100% urethane. Now, this unique material is available in different hardness and it's measured in shores. However, its big advantage for sidewall construction, even for the higher rated shores, is that not only is it strong and durable, it's got great dampening properties. So not only do you get a sidewall that's great at absorbing impacts, you get a sidewall that can also help absorb fatigue-inducing vibrations. Now, the second way to use the sidewalls to dampen the vibration is to add layers of dampening material into the sidewall during its construction. This system is used quite heavily by Salomon and involves adding a rubber layer into the structure of the sidewall. This helps absorb vibrations while still delivering that rigid feel that ABS gives you. So, that's our snowboard design and construction video series finished. I hope you found it informative and hopefully not too boring. Now, I appreciate we've gone into a lot of detail and that you're probably not really ever going to use this information for anything remotely useful. But personally, I'm a big believer that if the info's out there, there's no harm in knowing about it. So thanks for watching, and we really do appreciate it, and hopefully we'll actually get to see you out on the hill this season.